Hey, what's going on guys, xiangqi here. So in the last video we did implement the slide and piece attacks, so that apart from only considering the offset of where exactly the piece is about to be moving next, it would also loop over the squares along the attack ray. But the problem with that implementation was the lack of breaking out of that loop in case if we hit a piece. So it was only breaking out of the loop only in case if it would go off board. But what if what if it encounters a piece in between? So I've already implemented that, but just to give an idea, so probably yes. Yeah, just come in out this single line of code. This should be fairly enough. And let's adjust the board position a little bit. So let's consider the rook on the empty board, and this should be relatively fine. So assemble and upload 0200 run hex dump. And well, it seems like it's okay, right? So the rook is going left, right, top, bottom, and it covers all the squares. But what happens if, say, for instance, we put a pawn, let's say a black pawn here. So I put a black pawn here, and for instance, a black pawn just right above the rook. And assemble, and upload, and run, and have a look what we got. So say like it does go further on, so it doesn't stop when it hits a pawn. So that's an issue. So now how can we handle that? And also you need to bear in mind the fact, a very important fact for a chess engine, that if you're capturing something, you really need to remember that piece or whatever, yeah, that piece basically, because when it comes to taking the move back, you need you obviously need to restore the capture piece on the target square when you're taking the move back. So that's important. So we need to store this captured piece, and if the captured piece is not equal to 0, we need to drop the loop over squares along the attack ray. So it consists of two parts. So the first part is, yeah, so here we just capture, we just store a capture piece. So whatever we have at board indexed by the destination square, or board and on the offset storing the destination square. So whatever kind of we have there, we need to store it to the local variable called capture piece with an offset 7. So, and then we want to stop sliding on capture. So again, here we're just loading our capture piece variable and comparing it with the 0. So in case if it's not equal to 0, I mean, like in case if the piece is not 0, then we want to drop and literally to go for next offset. Yeah. So if I just assemble this again and upload and run in hex dump, and you see like the black pawn above, and it stops there by capturing that pawn, and also it stops here by capturing the pawn here. And also if you have a look at the stack, then we have this 12, which stands for that for a black pawn that we've just captured. So it also being captured in a local variable. So that's quite important thing to consider. So we capturing this, so that later on when we would be making the move and taking it back, we would be able to restore this captured piece, which is important. Okay, and also and also the matter of actually dropping on when there is something along the attack ray, when we're looping over the squares along the attack ray. This is also important because so the way how it works now, it says like if there is a captured piece, in this case we want to drop the loop. So in order to avoid leaper pieces, in order to prevent the leaper pieces from sliding, we need to mimic the captures for those pieces. But this is going to be the topic of the next video. This is it from my side. Thanks for watching. Until the next time, and take care.